Okay, so first thing I want to ask is, how many people here have you guys already had a microservices talk in this job, or is this the very first microservices talk you're having?
Yeah, we've had one or two. Yeah.
Okay, excellent. So this is good because, to be honest with you, I think this will be the microservices talk that you weren't expecting. I'm definitely not a microservices cheerleader, to be honest with you. If anything else, this will be the microservices anti-hype talk. So the title of the services, title of the talk, I hope I put in some effort into doing that. All of the words there are meaningful. I do intend to give you a more down-to-earth view of microservices. I've been a consultant for a very long time. In fact, I'm no longer with Oracle. I'm back in doing consulting. Most of my consulting is not with startups, not with high-tech companies. Most of them are, in fact, vanilla businesses, and that's what I'd rather be doing. So I believe my view is a rather stubbornly down-to-earth view, if you will. I hate pretense more than anything else. Technology pretense is the worst kind of pretense. It is about microservices, definitely. We'll be talking about microservices. And we'll also be talking about Java-E. And some people will say, hey, Java-E and microservices, that's an oxymoron. And as you'll see, I don't think that's in fact the case. In fact, I will argue that if you're going to develop down-to-earth, pragmatic microservices, Java-E might actually be the best way for you. Okay. So a little bit about the company that I work for, not too much. We're a full-service consulting company. We do everything from soup to nuts. We're not too big. We're about mid-sized, decent-sized company. Good values, do good work, so on and so forth. We do have a presence here in New York City as well. Okay, so here's what I would like to cover in the next hour, plus or minus or so. So first of all, it's good that you had microservices talks, because this will be the point of contention with my talk and the rest of the talks, and that it is going to be about definitions. So first of all, we're going to talk a little bit about what exactly microservices are. And then we're going to get into more of a point where I think I'll be saying things that you may have not heard from the previous microservices talks, which is what are microservices good for, actually? At the end of the day, what are they giving you? And what's the promise and what sort of nonsense? And then we'll talk about how exactly you can go about developing microservices using nothing much more than a very simple, basic vanilla Java-E tool set, maybe a bit more tools here and there. Okay. The other thing I'll tell you is, in general in my talks, I don't have Q&A in the end. So if you have questions, just ask them in real time, and we'll have a little discussion. I don't think this is too big of a group. This is one of the reasons I enjoy doing these job talks. So let's, if you have a question, have a comment, let's have it. Let's have it in real time. Okay, so here's sort of my bird's eye level view of microservices, a little bit of a background. The entire microservices hype worries me incredibly lot, because I am really worried that we're going to have a bunch of people that are going to go through a lot of pain and anguish before they realize what this microservices thing is about, and in the end, was it even right for them? It is definitely incredibly vague. Things in architecture are usually vague, but microservices is vague plus plus. And I think a bit of it is deliberate. And this is a very big problem. It's a very big problem in terms of practical adoption and getting practical value out of this architectural concept. And I really think there is space for clarity and space for real, if you will, truth-telling. Getting rid of the nonsense, getting rid of the hype, and really talking about, okay, what is the cost benefit out of this thing? The naming I absolutely despise. I think both microservices as well as the sort of the evil monolith that the microservices proponents keep talking about. I think both of those are bad terms. On the face of it, it's a little too black and white. Whenever you think of monolithic and you think about microservices, the terms are designed to evoke emotions. They're trying to get you to buy into this idea, and basically trying to tell you that, okay, if you're not doing this, you're doing something wrong. You're writing a monolithic application, and woe is you. I definitely do think it's very heavily hijacked by commercial interests, and that is why I believe a lot of the hype and the terminology built into it is very, very deliberate. And this is not the first time that this has been done to us. As technologists, our industry and our vendors do this to us over and over and over again. And so-called thought leaders are not to be forgiven for this either. They are also equally guilty of doing this. So it is, at the end of the day, people like us that have to call them out on it. You have to say, look, what are you doing here? Tell us the actual gist of whether this thing is good or not. Okay. The reality is that nothing in microservices is actually very new. The fundamental concepts here are very, very old, and we've dealt with the fundamental concepts of this for many years, and that is why we actually know a lot more about it than we realize. There's a lot about the trade-offs, the cost and benefits of it. If you look at it from a very, very clear-headed lens, we actually know about it. We know when to apply this and when not to apply it, and what benefits we will get and where this will hurt us. And these are, as I said, these are the long pedigree of these concepts. And in fact, the latest pedigree is really SOAP and ESB. In my view, really intellectually honest name for microservices really should have been son of SOA or SOA2 or something of that nature, because at the heart of it, that is really what it is. The fundamental, the similarities between SOA and microservices are far greater than the differences between them. It's simply introducing a new term. There is, at the end of the day, I think it will be difficult to argue that this is not essentially motivated by marketing concerns, not intellectual concerns. So let's think about a practical definition of what microservices are. And believe it or not, this was a slide that I spent the most amount of time, not even the demo, but just coming to a reasonable definition of what that is. And why did it take such a long time? It took such a long time because I had to read through the, laboriously read through all of the so-called thought leadership and all of the so-called academic work to finally figure out what definition can I come up with that I am okay with to say, to tell you this is what you're talking about, and I would feel good about it and really think I didn't cheat anybody today. Okay, and this is the definition that I've come up with. You don't have to agree with it; it's a starting point. Right? You can add, remove as you please from these concepts. So what I think microservices are is simply the idea of decomposing larger systems, not necessarily a very large system, okay, but a larger, by some comparison, a larger system, and breaking them into smaller, independently deployable parts. Okay, and smaller is in italics because it doesn't necessarily need to be very, very small. It just needs to be smaller than the overall whole. So it is all about relative concepts, okay, rather than anything else. It's a question of breaking things down into parts that make sense. Now, having given you that definition, then this puts the burden on me. Then I should also explain how my definition differs from somebody else's. So let's spend a little bit of time talking about that. So first and foremost, the purists will tell you, yeah, we absolutely want to distance ourselves from SOAP and ESB. If you ask them, hey, is microservices and SOAP and SOA the one and the same thing, they will tell you, oh, no, please, it's not something very different. The fundamental difference here is really what they're trying to tell you is that if you're doing microservices, you shouldn't be using SOAP, you shouldn't be using ESBs, you should be using REST and not have centralized orchestration and the like. I don't necessarily agree with that view. Okay, I think a lot of these concerns are also marketing driven rather than intellectually driven. What fundamentally you can say is that you shouldn't use SOAP, you shouldn't misuse SOAP. Right? It's irrelevant whether what protocol or specific technologies you are using to implement this concept per se. As long as you have a smaller systems that compose a larger system, whether you're using SOAP or REST is a minutiae detail. Okay, but am I advocating that you should use SOAP and ESB? Absolutely not. Okay, I'm not a big fan of SOAP or ESBs either, but they do have their place, right? And they have succeeded. There are successful use cases where these concepts also have been applied. So in my view, this is sort of an academic debate. You could be using SOAP and ESB and still be perfectly legitimate and say, yeah, we are developing microservices because everything that we are doing fits the ultimate goal of what microservices are trying to accomplish. As I said, purists will mostly embrace REST. Okay, so basically that's the equivalence there. If you will, a very simplistic troll would be, microservices is basically SOA for REST newbies, right? People that haven't lived through the SOA and ESB and SOAP world, and this thing is new to them because they're using a new technology called REST. However, it's not just REST. Let me emphasize that. The protocol is somewhat important, and even the microservices folks will acknowledge that at some level. Okay, specifically they'll tell you that okay, if you don't want synchronous services, and you want greater reliability, well, you can use messaging. You can use message-oriented middleware as a communication buffer between your services. Okay, and it doesn't stop there. The protocol and communication protocol, the way each of these components communicate, is sort of irrelevant. Purists, for the most part, will argue that in order to successfully execute upon microservices, you need to be you need to take for granted and be very good at automated testing, DevOps, and continuous delivery. But let's be honest for a second. How many of you would say that? Would say that you got it pat down. You automated testing, DevOps, continuous delivery, no sweat. I wouldn't raise my hand either. So this is part of the problem here as well. So yes, you do need to be very proficient at these things at a certain level. There's a certain variant or a certain way that microservices can be implemented which necessitate these things. Okay? So if you are using that variant, you have no other choice but to be very proficient at these things. If you are not, and if you are rather dealing with a more pragmatic view of what microservices are and try to derive their benefits of them, you need to be sort of good at these things. Okay, so you don't have to be masters of them, no better or frankly no worse than what you would if you were developing a monolith. There's value, even if you're developing a monolith, these are valuable practices either way. Purists also will focus very much on the micro part of the microservices. Really what they are fundamentally talking about is not distributed systems, but distributed objects to some degree. Okay, so that's the fundamental difference. Where things go on a different tilt that I don't think is very good is talking about taking the micro part of the microservices a bit too seriously. I don't think that's the case. I think fundamentally the micro part is not important, but the part that's important is actually services. So what is the promise? Why are we interested in any of this? So let's try to explore this a little bit. I've been developing these enterprise systems for a long time. Most of my life, most of my career using Java. What are the headaches? When I really think about what are the things that worry me when I take on a new client, when I'm given a maintenance assignment or a greenfield assignment? What are the things that I worry about? And what are the things that my clients worry about? Even not being a consultant, being in a place for 4, 5, 7, 8 years, what do they worry about? And there's really 3 themes that recur in my mind. One is requirements. In terms of designing a system that actually meets customers' requirements. This is actually a fundamental problem. The other fundamental problem always is actually resources. Okay, especially post-90s, we're still in a mode where we're asked to do more with less and more with less and less. Okay, so resources are definitely a problem. So how can you be more productive? How can you do things cheaper? How can you do things faster? Those are real concerns. Another big real concern is system stability. Nobody wants to get that call in the middle of the night that your system is down. We have, or in the middle of peak demand time to say, hey, your system isn't performing there's a bug, something is down, so on and so forth. So how do you keep things, how do you guarantee the systems are running in a stable, reliable fashion? That's another recurring concern. The fourth one, right down there, is software maintenance. How do I keep my software? How do I maintain longevity of my software? How do I write a software that I can maximize the investment that I made from that software? So believe it or not, if you take microservices too seriously and you really are whole hog, bought into microservices religion, let me tell you, the first 3 is going to be harder. Okay, it's going to be harder for you to meet your customer requirements on time. It's going to be, your project is going to be over budget, and your systems are almost guaranteed to be more unstable. Okay, that's a sobering reality. You should really internalize that. Where will it help you? The biggest practical benefit that microservices actually, in my view, gives you is that number 4, maintainability. Why is that? When you're dealing with the software system, I think all of us will acknowledge that software is subject to code entropy. As time elapses, software gets harder and harder to maintain. Code quality goes down, software complexity increases, and so on and so forth. Now, one of the observations that I think is fairly widely understood is that software entropy is also a function of the amount of people that work on a single code base, as well as the size of the code base in terms of simple things like lines of code. Right? Not talking about even metrics of complexity, but simply the size of the code as well as the number of people working. It's relatively human. Right? So if you have a large system that has a lot of intricacies, it's harder to make changes, and when you do make a change, well, you don't do such a good job. If you have 30 people working on a code base, there doesn't tend to be as much sense of ownership. Who cares? It's just, you're just another cog in the wheel, doing what you've been told to do. So that, I think, is a legitimate question. And as software architects, solving those problems actually does the modularity in particular and microservices. Those are legitimate concerns to solve those problems. So when you actually do have those problems, the system is just too many lines of code, or you just have too many people working on the same code base, a simple solution to that problem is, in fact, taking that system and breaking it down into sensible subsystems. Okay. There are other purported benefits. We'll talk about those in a second as well. But let's first explore a simpler, more fundamental concept. So let's say for a second that you are convinced that, okay, your system is too complex, there's too many people working on the same system, on the same code base, and you need to decompose the system. How would you decompose it? And that's an incredibly complex system. Whether or not you have a greenfield project or an existing project, it's a hard question either way. So sometimes system needs will make those lines of demarcation easy, and I think these concepts are best explained with examples. So one very common one is actually reporting. Reporting fundamentally is a different problem than your operational system. In fact, as we know, most of the time your reporting database is different from your online transactional database. So often it makes sense for reporting to be a separate module. It doesn't have very much interrelationships with the rest of your system. The other place where decomposition lines are relatively obvious is when it follows the natural hierarchy or natural composition of your organization. And again, this is best explained through an example. So one good indicator of this is that you have a system that you have a set of features that are used by a distinct set of users, and you have another set of features that are relatively mutually exclusive, and these two groups of users don't typically interact with each other very much. That's a good fundamental demarcation boundary. So let's use it. Let's try to explain this using an example. So one of the domains that I have a decent amount of experience with is insurance. Okay, so in insurance, you actually have many different people in the insurance cycle, right, playing different roles. You have the salespeople that that will say, "Hey, I'm selling insurance. Yeah, you're interested in buying insurance. Tell me a bit about yourself, and I'll give you a code." Okay, and execute the sale and so on. The data that these people actually enter in their systems, typically it's called a point of sale system. That information is actually goes into some backend system, into data, basically people that specialize in data entry. They look for completeness of information. Is the data accurate? Is the data complete? If not, they send some notification back to the point of sale person and so on. After this is done, it actually goes into another group of your information actually goes into another group of people called underwriters. Okay, and these are essentially specialized accountants. Okay, they can look at your information and run some algorithms and use their experience to tell you, hey, this is how much coverage we can give you. These are the premium. This is the premium we should be charging you so that it's a profitable business for us. Okay. And similarly, there's other parts of the insurance system. So there's billing, there's reporting, obviously, and disbursement and archival and so on. So each of these are actually distinct. Typically, these are distinct subsystems. It would be rather insane to have to insist upon all of these functions to be performed by a single code base. It would be millions of lines long. Right? So that is a sensible breakdown of the system because these are distinct set of users. So forgetting about that for a second, let's explore another question. So if modularity is ultimately what we are after, then why couldn't we simply implement it using the tools that we already have, right? Just in-memory modules, whether that's OSGI or simply breaking things down into Maven projects and having jar interdependencies. It's a good question. Okay, and frankly, you can argue back and forth about this question. My answer is that based on what I have seen, and I've tried to implement I've seen OSGI systems in implementation. I've seen sort of just Java packaging-based, Maven-based modular systems as well. The problem with those systems is it's really easy to break module boundaries. You can very easily introduce circular dependencies or interdependencies within those modules without realizing it, right? It's relatively complex to be very disciplined about not breaking those module boundaries. So the reason distributed systems win in this one aspect is because they actually physically enforce module boundaries. Right? You cannot break the module boundaries for the most part if you're using a protocol that does not support tie binding. Okay, so you'll have to work hard, against your fundamental infrastructure to introduce coupling. So that's why I do buy the argument that yes, if you're going to write modular systems, probably distributed systems is the way to go. So these are some of the other arguments that I don't quite buy. So I'll tell you these as well. We're told that microservices are easier to scale. So what is the fundamental theory behind this? The fundamental theory behind this is very simple. If you have more hardware, you get more performance. An easy way to get more hardware is break your applications down into pieces, okay, and assign more hardware to each of those pieces. The problem is that argument starts with a simplistic view of how to scale systems, because fundamentally we can scale monoliths. We can throw more hardware at monoliths, can't we? How do we do that? We've done this for the better part of 10 years, certainly since the late 90s. How do we do it? That's vertical scalability. Yes, you could do that, but what else? Horizontal scalability. Yeah, you just make a copy of your software, put it in front of a load balancer, and there you go. Right? You can make a copy of your system, and you can apply more hardware to it. And in fact, systems do scale this way, right? I've seen systems that scale up to 100,000 users, more than 100,000 users using exactly this technique, nothing much more. But there is a case to be made for distributed systems, right? So if you have millions of users, okay, if you are in eBay, if you're in Amazon, well, that's not going to work anymore, right? Because even if you were able to scale horizontally a given part of your middleware, you really wouldn't be able to scale your database. So fundamentally, it's the database that's the real hardware problem, because you can't horizontally scale databases in a meaningful way, right? So for that fundamental reason, if you have millions of users, right, if you exceed the vertical upgrade hardware capacity of your data layer, then you have a legitimate case for having completely distributed systems and subsystems that have their own dedicated databases and hence more hardware. Okay, so there is value, but not to most of us. Right? Most of us are probably not dealing with millions of users. I have personally, in my entire career, never wrote a system that has millions of users. I have to be honest. Right? I have written systems that have maybe thousands of users, maybe 100,000 users, but that's really about it. Okay? And of course, it's no coincidence that, of course, the people that are using microservices are, in fact, do have millions of users. Right? They're the Netflixes, they're the Amazons, there's the companies. Finally, there's another, another argument that's made in favor of microservices is that, okay, microservices enables polyglot programming. I sort of don't buy this because, one, I'm a Java bigot, and number two, I haven't seen it in practice. Okay. So how many software development managers do we have in-house? Okay. What would you like to deal with? A team that has a single skill set, right? A team of 5 people that have a single non-skill set that you can interchange? Or would you like to have a team of 5 people that have complete and do not really know each other's skill set that well? In their day job, they're really masters of maybe 1 or 2 languages, and they don't actually talk to each other much. They don't. Other than that, they don't know each other's skill set that much. What would be easier to manage?
I would prefer a team of T-shaped people who know a couple of topics, 3D, a couple of technologies in it, but are familiar with other technologies if they need to support it or if they need to change. That's what
Exactly. So because the fundamental problem is, you have to have people in most vanilla organizations. You just can't have people that are specialists in certain things and have a bunch of specialists working on a system that needs to scale. You do need interchangeable skills. Okay, and this is why in most most of the organizations that I work with, large organizations, they don't have 10 mainstream technologies in play. They're not programming in 10 different programming languages on the JVM, max 2 or 3, right? So for this reason, I don't buy this. This may be a benefit that you get out of microservices, but you shouldn't be adopting microservices for this reason. What you wind up happening here is that you'll have distinct components that are that is tied to specific skill sets of individuals, and it'll be very hard for you to interchange that team anymore because it's written, oh, this thing is written in Perl, this thing is written in Java, this thing is written in Scala. Well, how many Scala developers do I have? 2. Well, that component can only be managed by 2 people. Okay. Versus if everything is written in Java, well, I have 5 people that know Java, they can interchange their skill sets readily. Greater agility. This is actually a legitimate concern to some degree. And so let's talk about this one as well. So the issue here is really tied to basically deployment and testing complexity. Okay, so if you have a large, monolithic, large code base, it's going to take a longer time to deploy. Okay, and it's provided you are doing automated testing. Well, now for this large piece of software, you'll be running quite a few tests, okay, before you can reliably deploy that piece of software. if the piece of software is small, it's going to be easier to deploy, and there's going to be less tests you're going to run. So your net deployment time, for this component is going to be less than the whole. As I said, there's some benefit, there's some merit to this argument. In fact, this is one of the reasons why Netflix, in particular, people that have the problems of millions of users, but also are startups in nature. Right? They need a relatively rapid pace of change. This is a compelling. Compelling. This sounds good because you can have isolated groups of people that are moving at different velocities, and they can deploy quite quickly and whatnot. The problem is it has to do with how far do you go with this, and I'll discuss that in the next slide. Now, the other blurb I wanted to put in here is something called Ddd Bounded Context. I'm actually a practitioner of this thing called DDD, domain-driven design. I've done it for about 7 years now. Can anyone tell me why I put that blurb there? It's intended to be a puzzle on my slide.
Drawing lines around your services.
Yeah. The reason I have this is, how old is bounded context? The concept of bounded, it's 7 years old. So what's my point? The point is that if you're doing bounded contexts, you know what bounded contexts are. You know you got this. You figured out microservices already. Okay. It has very much to do with the concept that I talked about. It's about distinct natural boundaries of subsystems due to business reasons, business and system reasons. Right? They naturally emerge. You don't have to think too hard about it. Okay. That's what DD bounded contexts are actually all about. Okay. Talked quite a bit before I go into sort of the realities but the concrete downsides of microservices, and specifically in distributed computing generally, is questions, comments so far?
One more thing with the agility is concerned is like in respect to cloud environments is concerned. When we talk of monolithic services, like it's going to take more time to deploy, stop, start, and all these things, it doesn't conform to those 12-factor principles. If you have like a smaller microservices, which could just quickly deploy and go down and come back, so it becomes easier in the cloud-based environments.
Okay, fair enough.
I have something to add similar to that, but it's more about scalabilities. So we were talking about monolith, where architecture where you can have system and you can have under scaling with load balancing. Well, one of the things that I often encounter in cloud as well as in real world as well, like for example, I have a process that takes up about 58 gigabytes of memory footprint right now. And it's just that much harder to find servers with 128 gig. And we have a whole bunch of 32 gig or 48 gig servers around. And if we could break down in modular, then scalability does matter. So I guess that supplies some credence in support for it.
Some credence would be, I would say, is fair. So yeah, let's leave those. For now, let's acknowledge that there's some truth to that. Okay.
Well, it seems like your kind of view of this microservices really it varies based on what the definition of how your application is, like the scope of your application, your book of work. Would you say that the argument you're making is all around the book of work that one team is responsible for? Or, because in some senses, I think some of the arguments you're making, they kind of make sense if you were to think of, well, I'm splitting up these services, but I'm also splitting up the team members responsible, and they're now developing out their own features, and they're responsible for something else, and that's kind of really a separate service and sort of service-oriented sort of terminology.
So yes, I should. So yes. So correct. I implied that, but I haven't stated it. So might as well state it. So in microservices, actually, that is one of the implicit goals. So the way, if you let's talk not my version of microservices, but sort of the purest version of microservices. So when they are talking about essentially creating all these fine-grained components, for the most part, they are essentially implying the distinct sets of developers that are working on those services. Now, to be honest with you, some of the examples that I have seen, it is really distributed objects. So it's to the level where a single developer is probably working on multiple of one of these. It's not even a team. Right? But yes, that is, in fact, that's a Netflix model. Right? They have a microservice and they have, just a separate team that doesn't basically talk to anybody else other than their service contract, and that's a component that they're responsible for. Yeah.
And extending that with respect to polygon is concerned, like that could be we have seen in our organization that in a larger team there are sub teams, which are like maybe like 15, 20% of teams, which are working in a set of services, and then there are other set of teams which are other set of services. And we have a mix of nodes and Java web applications, so we do have a polyglot thing that happens in the world of microservices as well. And people who are forming the team will be working on node-related stuff, will be interchanging on the node-related services. And based on depending on various different requirements, one might choose one or the other set of technologies as well.
Okay, yeah, so again, that's the point that, just a clarification of what I said before. Okay, anything else? Yeah.
I guess so far I've not, I could not see whether it's actually for migrating or starting a new application. Migrating, I understand, is more challenge, but I think the cost of when you're building a new application, there are enough tools, I think that's going to be used. But again, I just wanted to.
Sure. Okay. All right. So let's talk about the reality of microservices. So what are the downsides? I mean, this is where most of the people that are talk about microservices basically gloss over, because they don't want to talk about it. These are inconvenient truths. So these are things that we've actually known about for a long time, because we're dealing with distributed systems for a long time. And this is one of the excuses that I hear when I talk to the microservices proponents. They say, when I ask them, hey, why don't you talk about these things? They'll say, oh, good, that's old hat, everybody knows it. I really don't think so. I really think we have forgotten these things. And that's why we're so overly enthusiastic about distributed systems again. And this goes in cycles. Every few decades, we get this enthusiasm about distributed systems. First and foremost, distributed systems are in net, significantly more complex to administer, deploy, and monitor. Okay? From a sysadmin standpoint, it's a lot easier to maintain a monolithic system because you're dealing with, you have your eye on a small amount of stuff, right? When you're dealing with a distributed system, well, you got to think about administration. You've got to keep an eye on the health of all of these things and make sure all of these things are up and running and happy. Okay, the deployment of a single application is easy, but deployment as a whole, it becomes a lot more complex activity. Okay, because you're suddenly having to deploy multiple things, and it gets even worse if one thing that you're deploying actually has a indirect dependency on another thing that you are deploying. Hard testing, debugging, and diagnostics is incredibly harder. Okay, because suddenly if you do have a failure, let's say in your test, well, you don't know if that is a failure of your test, or a failure in some other dependent component or some other dependent component on that. And similarly, debugging and diagnostics is the same story. It's even worse in a production environment, and if you suddenly encounter error, well, you don't know where that error actually is coming from in a distributed system. In the worst case, it may be being written by an entirely different team using an entirely different language, that you have no real control over. In a monolithic system, that's just not the case. Also, reliability and consistency is basically, you can take that for granted in a monolithic system. The reason for this is transactions. Right? So if you have a local transaction, well, you can guarantee consistency right there. Right? You know that you have an atomic success or failure. But guess what? When you're dealing with distributed systems, unless you are using Corva or distributed transactions, which they're telling you, not to use, well, guess what? Then you're stuck with REST, which doesn't have any transactional capabilities, right? So if you have to enforce transactions across interdependent services, well, you can't do that anymore. Okay? So this is actually a very big concern for reliable systems, is how do you now guarantee atomicity? We cannot guarantee atomicity across a REST-based distributed system. Code duplication will be a reality of life for you in microservices. Let's take the simple inference example. So in that inference system, although there are distinct, actually quite coarse-grained subsystems, okay, those subsystems actually do wind up sharing some data. At the bare minimum, they share information about the actual insurance policy or the policy holder. Okay, so that data will get propagated one way or the other. So when you introduce changes, you have to make sure to introduce changes so that those changes get propagated into all of these systems now. So you will have duplicate copies of that domain in some shape or manner. You can try to control that. You can try to minimize that, but it is a reality of life of distributed systems. And it does not exist in a monolithic system. You need higher skills and automation requirements for development and operations. Okay, so distributed systems are inherently more complex. They require more technological moving parts that you need to learn and you need to execute and you need to master. There's two other things that are a little too large for me to discuss, but I would like to introduce these terms just so you can think about it and maybe search a bit more about it on the web yourself. One is a term called distributed big volume mod, and I'm very thankful for the person that actually came up with this term, because I've seen this thing in action. So one of the arguments against monolithic applications is it becomes maintainable. It is subject to code entropy, and it becomes a big volume mod that nobody wants to maintain. Well, guess what? If you experience entropy in this world, okay, you're not only are you going to be dealing with a big ball of mud, you're now going to be dealing with this big ball of mud that's distributed. Okay, so it's not just harder to maintain; it's also on a system that is on a network. Okay, that has to communicate with each other. The other one actually is fundamentally important as well, and this is an old one. It's not a term that was coined new. It's called the fallacies of distributed computing. Anyone know who came up with this term?
Deutsch.
Yeah, exactly. Yeah. So there's several of these. I'll mention the most important one of them. One is assuming that the network is fast, which is not. A network has latency. There's transport latency as well as serialization latency. The network is reliable, it is not. You can have any points of failure on a network. You can have a machine fail. You can have a wire being pulled from your router. You can have the router fail. Okay? The network is secure, it is not. Okay? The more network nodes you add, the larger attack surface you have that you need to secure. The network is homogeneous, it is not homogeneous. You can have multiple subnetworks that are maintained by many different folks. So all of these are complexity vectors that you need to deal with, okay, in distributed systems. They don't just go away. Right? These are realities of life as well. Okay? And the more distributed the system is, the more you will be dealing with these issues. Okay. So what is the bottom line? In my view, this is the bottom line. I do think that in 5 years' time, I think still a majority of systems will actually either will be fine or would have been fine as just monolithic applications. Okay. I do think that a majority of systems that need microservices are not going to meet the definition of the purest microservices. I think they will look a lot more like traditional SOA-based services that are large-grained subsystems of a holistic system. Okay? These are not going to be trivial systems on their own. Right? The insurance one that I talked about would be a good one. Right? So these subsystems are not trivial. Right? There's 5 or 10 people working on each of these subsystems. They themselves are probably close to 1 million lines of code in order. Okay? So these are not just distributed objects. I do think there is a place for microservices nirvana, sort of the canonical view of what microservices are. I do think this is a niche. Okay, I don't think a vast majority of us have a legitimate need to go here. Right? There are people that need to go here, but I don't think this is most of us. Now, one of the very nice things that happened in this case is that I can actually demonstrate this graphically. Okay, so often they say a picture is worth 1,000 words. I definitely think in this case it is true. This is actually a diagram of a real-life production system. Can anyone guess what this is? Who this is? It's a company that I mentioned. Netflix. Yes. This is the only known, system diagram of Netflix's overall system. This is one logical system. This is the video streaming system of Netflix. Okay. Think for a moment whether you want to deal with this or not. Right. This is microservices nirvana. Each of these are systems that have all these interdependencies. They all have their own dedicated data source, and most of these services probably have no more than 4 or 5 calls, that they expose to each other. Okay? So I don't think most of us are ready to go here. Any questions on any of that before I move into sort of the Java E variant and where Java E fits into this picture?
So the diagram that you showed, right, I to a great extent agree to it, but also what I've been trying to look in the industry around it is like how could it be auto-generated rather than manually maintained, because manually maintaining this is basically a nightmare. You cannot do it, especially if you're scaling up and down. You need to know the instances of each of your service and how the interdependencies are there, and which service depends on which over a period of time. If you're maintaining manually, it's just not possible.
Believe me, this is the oldest argument I've ever heard. When back in the day when people said EJB2 is complex, the answer always was, what do you mean? You have IBM Rational Developer. You can tool away all this complexity. You can only tool away complexity. You can manage complexity with tools, but it doesn't go away. Okay. All right. Moving on. Okay, so microservices and vanilla Java E. So one thing I will tell you right away is that in my view, this. If you take a canonical view of microservices, and that you want that sort of Netflixy type of model, vanilla Java E will not do for you. Okay, there is other Java E based answers for that question. I'll explore that in a second. But if you are convinced that that's not for you, and really what is right for you is coarser grained services, that really look like subsystems of a larger system, actually Java E is the right fit. Okay, I'll tell you why. So first, let's talk about sort of API feature set wise. Okay, what does Java E give you? So actually Java E gives you quite a bit, because Java E's roots are actually in distributed systems. So all the pieces there that you need to have distributed systems are actually already there. So first and foremost, you need a remote communication protocol, a way to communicate remotely with your components. And actually Java E has quite a few of these such capabilities. So there's JAX-RS if you want REST-based communication. There's WebSocket if you want WebSocket-based communication, which also, by the way, is a legitimate protocol for doing microservices. If you want to do messaging, well, we have an API for that. That's quite old and quite stable, called JNS. If you want something beyond that, if you want to use SOAP, we have JAX-WS. If you want to use RMI, we've got EJB remoting for that, or just vanilla RMI for that. Okay. The other key piece that you need is something to do data serialization and deserialization and serialization. And well, we have all those fundamental pieces in place as well. Okay, Java E has support for JSON, which is what you would want to use most of the time. If you want to use XML, well, there's JAX-V and JAX-P to do that. Of course, if you want to use Java serialization, let's say with JMS, well, that comes built in out of the box as well. Beyond this, you have basically all of the other pieces that you need to develop functional systems. If you need a UI, well, there's GSF, there's a framework to do that. That's built into the platform. If you want transaction security messaging, all that is built in HAV3. If you want dependency injection or AOP, that's in CDI. If you want access to relational or non-relational databases, you have JPA. Beyond this, though, application servers themselves actually have a very mature feature set for doing distributed systems as well. These are not APIs, rather these are administrative capabilities. So these are things like administrative consoles, right? So administrative capabilities, whether that's command line or based on a UI. Similarly, there's capabilities built in for monitoring. Most app servers today have long supported JMX, and these days they actually also support monitoring via REST APIs as well. Okay? You can also have high availability. Horizontal scalability is really not much of an issue. You can secure either your application or the application server itself. And you can also do resource management. Okay, so you have pooling capabilities at the connection level or thread level or whatever level that you want. So a bunch of resources that are important enough even for monolithic systems, and also equally important in developing practical microservices. So I do have a demo for this. I won't show you the demo too much of the demo because I'm sort of running out of time. If I have time in the end, I'll show you the demo. But basically, if you go to this URL, there's step-by-step instructions on how to set up the code. It will be it's essentially a practical implementation of a Java EE system. Okay, it's not too crazy. It doesn't have much of distributed objects. It just has some sensible services. So we should talk about the microservices buzzword bingo, if you will. Okay, so this very much reminds me of SOA and ESBs back in the day. So, whenever people talked about SOA, they automatically assumed you're using ESBs. Okay? If you've got to do SOA, you've got to be doing SOAP and you've got to be doing ESBs. In reality, neither of which is actually true. Okay? Fundamentally, so SOA was nothing much more than an architectural technique. Yet again, it was completely unimportant what the implementation details or the technology details were. What happened was vendors essentially hijacked that and equated that to SOAP and equated that to ESBs. Same kind of thing I believe is happening here. Okay, so I'll talk about what these few things are at a very high level. So there's fat jars, containerless microframeworks. Fundamentally, what do these things do? They basically, what they do is that they help you bundle your runtime in your executable. Okay, so instead of deploying your application to a framework, to a runtime, like the JVM or like an application server, basically you're bundling all of your dependencies into your jar file and deploying and executing that. And there's a bunch of variants of this. There's actually a bunch of Java EE variants of this as well. So Wildfly Swarm, Pyra Micro, Akumulo Z, Tommy Embedded, all of these will essentially provide the same APIs that you would in an application server in the vanilla Java EE platform, and they allow you to bundle these as fat jars. Okay, Spring Boot does the same thing also in the EE world. Docker, again, usually co-bundled with microservices. Sort of the implication is that if you're using microservices, you better be using Docker. So the problem here is that Docker is on its own a good technology, okay, but fundamentally there's nothing microservices that much about it. What Docker actually helps you do is that it is a better alternative to heavyweight virtualization. Fundamentally, that's what it is. Right? And again, God forbid you'll get a vendor to admit this. Right? But that's really fundamentally what it is. Where you would use virtualization, you can now use Docker. You can overuse virtualization, if you will. But there's fundamentally nothing wrong with just developing microservices and deploying it without Docker if you want. Right? If it doesn't make sense for you, it doesn't make sense for you. In fact, in many cases, I see an overuse of Docker. So think about this. So the religion that's being sold now is that Your deployment unit is your Docker image, which means basically you're deploying your entire virtual image of your operating system each time you make a code change. You made a 10-line code change. You want to deploy your entire VM. Tell me that makes sense. Okay. So there's a bit of nonsense there, and cloud PaaS, again, same kind of co-bundling going on here. You're going to use microservices. Of course, you're going to do it on our cloud, right? Well, the issue is, cloud is not as straightforward as you think, right? If you have an honest conversation with most CTOs, they will tell you that cloud is not saving them money in the end. At least not now. Maybe 5-10 years down the line, cloud may save money. Right now, all that it is really buying is that it's allowing you to fire your IT, so dev operations folks. That's all it's fundamentally doing. You have less people to manage, but you're probably spending the same amount of money or more. In fact, I actually recommended to a mid-sized client just a few months ago. Look, don't go to Amazon. It's going to kill your budget, IT budget. Right? So if you don't like your operations people, fine. But you know what? They're saving you money at the end. Go get rack space. Go rent a data center, and it will actually save you money in the end. So cloud, whether it's cloud or not, it's actually again a distinct decision. Just because you're doing microservices doesn't automatically mean you need to do it on the cloud. There's also a set of Netflix APIs like Eureka, RxJava, Hystrix, and the like. These are very much, they very much remind me of ESBs. Okay? So these are point solutions to specific problems that you may or may not encounter while developing microservices. Okay? So again, there's an automatic equation of saying, if you're doing microservices, well, you're going to use these tools. No. Right? You have to properly evaluate, do I have that problem? Right? Do I need dynamic discovery? Do I need circuit breaker pattern? Do I need client-side load balancing? These are all legitimate questions on their own end that you have to answer on an ad hoc fashion, rather than simply saying wholesale, I'm doing microservices, hence I better be using these tools. Moving forward, sorry. Okay, so there are a lot of these microservices fat jar solutions in particular that I talked about. They actually have gotten together and sort of developed, created their own little consortium. Okay, so to co-market, to say, hey, we are giving you microservices capabilities using the Java EE APIs. Okay, so that's microprofile.io. If you want to find out more about them, just log on to microprofile.io. They actually have some good stuff in there. And in fact, in one of the variants of my demo, I do use Wildfly Swarm. Okay. So I'm going to gloss over the summary just a little bit. So in summary, don't be too scared of all microservices. It's actually not beyond all the smoke and mirrors. It's actually stuff that most of you actually either know because you've seen this before, or know because you have an implicit understanding of how modularization should look like. It is an architectural technique. It's something that you need to have in your architecture tool belt. But like every single thing in your tool belt, you have to be judicious in, do you actually need it or not? You shouldn't be using it just because it adds something to your resume. And believe it or not, if you're doing practical microservices, Java EE actually gives you quite a bit. Wish I had time to do the demo. I would have shown you in person why that is. But it's actually not that important in this case. And the Java EE ecosystem actually is dealing with even with the niche of microservices largely due to marketing pressures. And so every other vendor is doing it, so the Java EE vendors are also. Few resources that I'd like to point out, I definitely recommend them. So when I give you my bottom line, just to tell you I'm not completely crazy, okay, go read this article by Martin Fowler. He'll basically tell you the same thing. Okay, he'll tell you that most systems actually don't need microservices, and microservices do have their downsides, so you have to take it very gently, okay, and not go whole hog at the same time. So go take a read of that article. The one thing that I still really don't like about Martin Fowler's approach to microservices is that he refuses to acknowledge that microservices and SOA are actually the same thing. So I found an article out there by a very tongue-in-cheek article that basically calls him out. Okay, that says microservices, hey, Martin Fowler, microservices and so are in fact the same thing. If you want to find out more about Java EE, take a look at that tutorial there. I actually, the last thing that I want to give you above and beyond my demo code is simpler. This is a bit more complex. I actually did a day-long workshop where I took a monolithic Java EE application and broke it down into microservices and added a bunch of bells and whistles like fat chars using Wildfly Swarm and dynamic discovery and Docker and AWS and all that stuff. Okay? So you can do it, and we'll show you, how you can do it step by step using the Java EE APIs. That's a last link there. Frank, how much time do you have?
1 minute.
Okay, I will do a 1 minute demo. Okay, so here's my demo application. I have two components to it, Cargo Tracker and Pathfinder. Cargo Tracker is largely a monolithic application. Okay, it's written in Java EE. Pathfinder is a much smaller service that looks a lot more like microservices. Okay, I don't have time to tell you why it's designed this way, so you can take a look at it. The one thing that I absolutely want to show you is this. Okay, this is running on Glassfish. Sorry, I'm going to do a clean and build. This built in 1.67 seconds. Okay, I'm going to now run it. It deployed onto Glassfish in 295 milliseconds, less than a second. Okay. Now, same thing I'll do with the Cargo Tracker monolithic application. I'll do a clean and build on this. This took 4.47 seconds to build. Okay. Now I'm going to run it. It took 2.19 milliseconds, 2 seconds to deploy. Okay. This code is about 15,000 lines of code. There's about 150 Java source files in totality in this application. You're not going to get this kind of performance out of anything, this kind of deployment performance out of anything else other than Java EE, amongst many other characteristics. Okay, and this application fits every definition. Fits the definition of what I told you, what my intellectually honest definition of microservices are. Okay, so take a look at it. You may be surprised as to what you find. Okay, all right. Thank you very much. I appreciate it. I hope you got something out of it, and